Thank you.
All right. Hello, everyone. My name is Manish, and first of all, thank you for the organizers for organizing this amazing event. I've been to a lot bigger events like AWS reInvent, Dreamforce, VMware World, but this is more engaging. This is more fun, and I like it. So thank you for the organizers. All right. So where's the clicky thing? Okay. Who am I? So I'm a lead uh, software engineer at Salesforce. My team name is Platform Engineering, and we do everything from system administration to writing APIs. So I guess titles doesn't matter as long as we are getting paid good. I'm based in Indiana, which is it's 4 hours south from here. And if you guys don't know where Indiana is, and so I have 18 years of experience. I've done everything almost from desktop support to platform engineering, again, writing APIs. It's fun. I'm passionate about technology like everyone else here. And also, when I'm not at work, I like to do home projects or whatever my wife asks me to do. And there's also like to speak at the public events about like fitness or kidney disease awareness. I'm not into fitness anymore much because food took over the priorities, I guess. And I want to reflect a little bit more about uh, mental health, health or because I want to reflect on Michael's talk or Chris's talk. I really want to say that you should always prioritize on your mental health or personal well-being. I have a story of myself. So like 10 years ago when I was 27, 28, I got diagnosed with kidney failure, like both kidneys failed. And 2 months later, to make it worse, I got laid off. And then my wife wasn't working, so I didn't know what to do back then. So yeah, and then I got laid off from a company where I was MVP six months ago, so they didn't care. So your mental health and your personal well-being always comes first. All right. What we're going to talk about today. I know we always talked about cool stuff, Kubernetes and all the cloud native stuff, and Docker, Terraform, and all the other cool stuff. So I'm going to go talk about a little old school stuff. You know, what's cloud computing, what's on-premise infrastructure, SQL databases, Windows, PowerShell, and some APIs and EMC storage. So let's get into that. So before we get into that, let me ask, do we have any database engineers here, database admins? All right. Okay, there's one. Okay, awesome. Any storage administrators? Nope. Okay. All right, it'll be fine. You'll learn something. All right. So, okay. So cloud computing. Let's talk cloud computing. I know it's great. It's flexible, efficient, accessibility, flexibility, innovation, opportunity, scalability, flexibility. If you get all that, it's pretty good. It's really good. And then a lot of people say it's the past, present, and future of technology, which I couldn't agree more. And even our CEO says it's a democracy in technology. So which is cool. I couldn't agree more. But cloud is cool. It's great. It's pretty good. And but is it the answer to everything? Is it the right solution for every infrastructure for every organization? Maybe not. I mean, cloud is great, but it has all the benefits, but cost is probably may or may not be the main one. All right. So what about cloud computing on the organizations or systems where, like they work with large, like really complex data sets and perform many mathematical calculations at like really fast speed. Like pace is everything, scalability is everything, and latency is everything. So is cloud computing the best solution? No. And so yeah, on-premise. There comes the on-premise infrastructure. And if you guys can see, this is my first personal speaking gig, so I apologize in advance. I might be a little, I don't know if I'm doing okay, but we'll go through it. All right, so managing on-premise infrastructure is no joke. If you know, it's they have to deal with so many things, managing all the hardware, building new servers, decommissioning them, renewing them, recycling them, and also those hardware break fixes, and working on those hardware issues. And I've done this. I've done this like 12, 13 years ago. I was trying to trace a network cable to the NIC card on the server. So yeah, it's different. It's painful, but sometimes you have to do it this way because sometimes when you say like latency is everything, when like 1 to 2 milliseconds latency is slow, your systems need like faster. So then, the cloud computing doesn't provide you that compute power, that scalability, but the on-premise infrastructure would give you all that. So yeah, cloud computing is good, but I think on-premise wins over cloud computing at a lot of different places. All right. So yeah, also about, those of you who do not know much about data centers and on-premise infrastructure. So cloud computer is good. It's less headache. It's not cheap, but the on-premise, there's a lot more factors. It's a lot more headache. It's to manage them. Like people don't realize that, for the bigger organizations, like running out of space in data centers and also the power and the cooling, that takes up a lot of time, and then your money goes into those things a lot. So yeah, on-premise is a pain. It's a giant pita, but it's kind of wins over a lot of things. All right, so how do you manage a big infrastructure? Where like your data centers are geographically located at multiple countries, multiple cities, and then your application connects to all the different data centers. How do you manage like huge data centers? How do you manage huge applications running on different servers, like we talk to each other? So there we use some of the DevOps methodologies, DevOps mindset to build those kind of infrastructure which can scale down and scale up in like really fast. So how do we do that? Right tooling, invest in right tooling. At bigger companies, I know like Salesforce, you name a tool, we have it, right? We have invested big on tools. We got all the tools. Like for example, Dora. I was, it was a good talk about Dora yesterday, and I was like, how have I not heard about Dora? And then I looked at the Slack. Okay, they got like 30,000 messages returned on Slack, so we are one of the biggest customers of Dora too. So build automations. That's the key for building or managing the larger data centers or larger infrastructure. So my application talk to your application. Teams don't have to talk to each other. Infrastructure as code, which is huge. This is what I do, what we do. Like everything should be built or decommissioned or moved or done using a click of a button. You don't have to like go or do something or go log in anywhere. That's what we say, that if you have to log into a server, it's a bug. You should not never log into a server. It should be automatically fixed. From the time it's built and from the time it's decommissioned, it should be all automated. It should all be click of a button. Building self-service tools for the dev teams and the other teams that you interact with. Build them these self-service APIs or tools so that they can directly talk to the APIs or the tools. They don't have to talk to you. And documentation, which is really important. A lot of times we try to work on something which is already done, and then you spend a lot of times working on something which somebody already did it like a long time ago and like well documented, well written. So and also, if you have like a bigger team and you did this once and next time your team member has to do it, then the documentation comes in handy. All right, API-driven architecture, which is my personal favorite. We write APIs like with Salesforce or all the bigger organizations, they know there are too many different teams. Like every infrastructure has like 20 different teams. Like how do they talk to each other? How do they like do a handshake? How they get or post or get the information from each other? It's all API driven. You build API microservices. Okay, my API talk to your API, and that's how we're gonna get the information or do a handshake or transfer the information. Cross-team collaboration. It's one of the same thing reflect on API-driven architecture. So you interact with a lot of other teams, and again, it all has to be API-driven or self-service tools. Nobody has to raise user stories or talk to other teams. It all has to be automated. That's one of the things. and breaking down in silos, which is another big thing. A lot of teams work differently. Daily stand-ups help, but sometimes you're trying to get something or implement something on your team or your automation, which is already done. Like some other team on some other org already done that, and you're just wasting your time just reinventing the wheel. So yeah, breaking down silos. So how do you do that? We do like demo days, like once a week. All the infrastructure teams or the database teams or even the dev teams, we meet up, we do the demo days, we select like which is the right topic to do, like similar as the open spaces. And then they would do the demos and they ask questions, they share their Git repo link where they can see the code. So things like that. And for my personal favorite, I love Slack. I'm sure all of you love Slack. Not the reason that Salesforce owns it, that's the reason I love it. It's a great tool. And then this is Slack is my go-to tool, like for everything. Like if I want to search something, I just go to Slack. Okay, type something, it'll just show me the results. And then I go to Confluence or whatever, and then find out what I'm gonna do there. So yeah, so Slack is great. All right, let's move to the next one. All right, so in particular, I'm gonna talk about just one automation we built some time ago, a few years ago, which is saving us a lot of headache, a lot of time, and a lot of money. So it's alert-driven storage provisioning on SQL servers. So I know you're all DevOps people. I mean, I'm a DevOps too, but this is more about the physical side of the things, or the other side of the automations or the infrastructure. So we have like applications running on this, so they're running on servers, but on cloud is great, again, as I said before, but what if it's all physical? You have a physical server located at a data center, attached to a storage array, and then running on a Windows server. So how do those three things interact? How do they work together? And then how about when the scalability is a thing. Your databases grow in terabytes in a day, and then you have like scale up or down like really fast. How do you achieve that? And so that's what we're going to talk about. So alert-driven storage provisioning on physical SQL servers. All right, so long time ago, not too long, I guess 4 or 5 years ago, our database teams were similar, like Red Hat's SRE teams. We were getting paged every 20 minutes because the storage or the databases were getting full, and they would get paged, and they would have to like put in a request, hey, can you just add more storage to this? And it's not like right-clicking or extending storage. It has to go through 2 different teams. They go to storage team, and then they would do the extension on the storage arrays, and it would come to Windows or Linux, and then do the operating system part. So that would take like hours, sometimes days, depending on how big the request is. And so yeah, we could not handle that. With the scale we were growing, that was getting a big headache. We were getting like dozens to hundreds of requests a day, and then this has to be automated. So there was a big need there. Also, we wanted to do like scale up or scale down like really fast. And again, the databases were growing fast, so we have to build new customers or extend new or existing customers. So also the turnaround time, as I said, it used to take like hours or days to do that one simple thing. Now it's down to minutes. The other one was the automation to run automation, because initially, like somebody from or database teams would do something that, okay, I need this thing extended, I need this thing added to this database. So it's all manual. So now it's alert-driven automation, kicking automation, which is great, which is really nice. And also the major or the biggest thing is saving cost on the infrastructure. So, EMC storage and SQL licensing and Windows licensing, it's not cheap, trust me, it's really expensive. So with this automation, we are able to move around databases from like one server to another, and then also reclaim some of the stuff that we don't need. Okay, we were just paying for it, but it's sitting there, not being used. So we were able to just remove it and then reuse it. So that cost saving is a major factor. Like I'm talking millions of dollars. So what we used, as I said, we used some of the DevOps methodologies and DevOps mindset. And some of the tools we used was Jenkins. I mean, I used to love Jenkins, but not anymore. SQL, PowerShell, Python, Go, all these story stuff was written in Python and Go. Swagger API platform, and then also Beluga, and we use Zeus API gateway for authentication with Okta. Splunk, and my favorite tool, Slack, and then Git, and also we send out the SSRS report for all our customer to see what's going on. So these are the tools, and all right, so this is like a high-level workflow diagram of what we're doing. I try to simplify it, but I know it still looks a little complicated. So looking at the left, let's say database is getting full, okay? Like database ABC got full and got utility database alerted, like, okay, all right, I'm getting full, I need more storage. So the alert kicks off, and then it goes to the API, and then the API sends it to the SQL database. So here's like one thing, because we evolved a lot. It used to be like when the alert gets generated, we used to kick off a Jenkins pipeline, and then Jenkins pipeline would do submit a request for the Beluga API or the Swagger API, and then also record to the database. But that used to take a lot of time, and we were not as big before. But now we're handling like hundreds of requests a day, and then Jenkins is slow. It's not built for scale, so it's causing issues. So we got rid of that ingestion thing, so we moved to the API, and now it's going directly to the database. And now we have a Jenkins scheduler job, which picks it up and looks at the database. Hey, you got any new requests for me to process? Okay, it pick it up, and it'll start working on it. And then for you who have not worked much on Windows or SQL databases, there are usually like three kinds of work which needs to be done. You provision new storage. Okay, you have a new customer, you want to onboard a new customer on a database. So you like mount or provision new ones on the clusters. And you want to expand your existing database grew, and you want to extend the storage on the existing databases. So that's the second category. And the third one is you decommission the database, or something moved to somewhere else, and now you want to return or remove that storage from the clusters. All right, so as you can see the workflow, so there are three different pipelines that are run in Jenkins, and every pipeline has branches. So in branches, there are like dozens of branches running at a time. And there are a lot of complexity to this workflow. I mean, every pipeline consists of like 8 to 10 jobs, because it's touching so many systems. There are too many moving pieces. So that's the overall picture. So yeah, Jenkins parallel branching, and then also Beluga API or the Swagger API is the main driving factor for this automation. All right, so the big picture, the benefits. Again, I talked about we were able to complete thousands of requests in a month. The turnaround time is 30 minutes or less, which is saving us a lot of time, because as I mentioned so many times, that databases grow by terabytes in a day, and then on our busy days, they grow like really fast. They grow every hour. So if you want to database grow and you want to expand it, give more storage to it, you cannot wait. 10 to 15 minutes is enough time, but it used to be like hours. So that saves a lot of time, a lot of headache for our database teams. Major cost saving on infrastructure. So we are able to scale down really quick, return any storage that we don't need, and that's saving us a lot of time on licensing, on SQL licensing, and then the EMC licensing. So licensing is really expensive, and so as the EMC storage. No manual work. 6-7 years ago, we used to do this manually, and now if we want to do it manually, it would take like team of 20 people just to doing this work. So yeah, that's saving a lot of time too. And again, flexibility to scale down or scale up. And then high database availability. I mean, availability is everything for us. Our database has to be up over 99%. So again, so this is happening on the production databases, on the production applications. So anything goes wrong, it's going to take the application down or database down, and we cannot afford that. So this is happening direct on the live customer. It's not you deploying code somewhere. It's happening live. So it's another risky factor in this automation. All right, meat and potatoes, and how we are able to achieve such a scalable automation. So every little details gets written to the database. I'm going to go back to the previous slide. So as you can see in the branches, so everything it's done, and it's get written back to the SQL database, because we have written our code and made it more idempotent, because you can't trust Jenkins, as we all know. It's going to fail. It's going to run only like 70 to 80% of our times at best. And then Jenkins job is going to fail, right? And then your code should be idempotent, and it fails. Next time it runs, you're going to pick it up where it failed and then complete it. So so everything on this automation is tracked using the status on the database, so that it fails at any given point. The next scheduler job will pick it up, and then we'll pick it up from the place it failed from last time. All right, let's move to the next one again. So as I said, that everything is tracked based on the status of the database, status ID in the database, and coded idempotency for to achieve the resiliency, and Jenkins parallel branching, which it's all right. Hundreds to dozens of jobs run every at the same time, which is amazing. I mean, it used to be like 4 or 5 jobs a day, and now we're like hundreds of jobs a day, which is great at the scale we operate at. Splunk dashboards, we have like Splunk dashboard. Everything gets sent to Splunk, so that if somebody else wants to see what's going on, or look at the database and how many requests we completed, or how many storage we provisioned, it's all there in Splunk. Slack notifications. Slack, again, my best tool, favorite tool. So every notification gets sent to the Slack, and we know, okay, something has failed. And also PagerDuty integration, we already have that too. So like whenever, as I said, the code idempotency, like if the job fails, Jenkins fails, it's keep on retrying, and once it tries for 5 times, it fails. It's gonna say, oh shit's not working. It's gonna page the teams. So then somebody has to take a look at it. All right, challenges we faced. Jenkins is the major challenge we faced, because initially when we started doing this, we were like, okay, we're doing 10 to 20 requests in a day, and maybe less than 50 a week. So Jenkins was fine. If some fails, we manually look at it and we fix it. But now we're doing hundreds, so Jenkins is not built for scale. That's why we have to do like a big improvement on the code idempotency, because if it fails, or next time, hopefully it'll be fine. Centralized API systems. We built a lot of API interfaces, microservices, and API, so that we're trying to move away from Jenkins and moving like a fully API-driven architecture of this automation, so that we don't want to deal with Jenkins anymore. And sometimes cross-team collaboration, it sounds great, it works most of the time, but sometimes it's gets a little tricky. I mean, some people are not as flexible as you want them to be. All right, so again, me complaining about Jenkins again. So as we started, like we wanted to do like, we started with like 5-10 jobs a day. Now we're like 500. It's my favorite Pawn Stars meme. Okay, we wanted to do like 500 at the same time. The best I can do is 25, which only runs 50% of the success rate. All right. Okay, so as I was saying initially, there are too many things we do with managing the bigger infrastructure. That involves a lot of things. So I'm mainly focusing on this talk is about databases. So the other major thing is we do about databases is moving around databases, right? Like you have, SQL servers. You have like 10 instances running on 4 clusters or whatever, and then one of them wants to be moved because the other database on the same cluster got busy, and that's using all the IOPS. That's taking a lot of resources on the server. So you want to move them, and you move them fast. So this kind of automation helps with like moving one database instance to another server, so that it's gone to a better server which is not using that many resources. So yeah, in similar automations to manage, again, high scalability. As I said, that everything we want to do is infrastructure as code. We want to do automate everything possible, right from like when the server is built, from the time of the server is built to the time the server is decommissioned, it's out of the data center. Everything should be done with the click of a button. So some of these automation includes automated hardware repairs, which sounds almost impossible, but we're doing it. 80% of the hardware repairs are fully automated. We hit the HP API endpoint or the EMC API endpoint, and also I think with the VMware too. So we don't have to create manual cases or anything if something goes wrong. So it's the case is created, they send out the technician, and then they work with our data center guys to fix that problem. So database failover. So if you're not familiar with database failovers, you know, when you're running, trying to achieve 99% availability, but you also want to patch your servers. You have to fail over the databases to the other servers so that you can patch and reboot them. And with SQL servers, the database has to be taken offline in a good way. You can't just right-click offline it. There are a lot of transactions running. There are a lot of backups or restores running, so you have to stop them. So they're like, our automation runs a lot of sprox on SQL Server, and then it stops the database, and then we take it down and move it. So that's again being done with all the cool automations we have built. Same with the SQL Server patching, and also physical server decommission. So it's all done using an automated way. And also the storage SRDF cutovers. I'm not going to bore you guys talking about storage again and again. So it's like decommissioning of the or renewing of the storage arrays. Like old is we're going to recycle it. Okay, it's end of life, and they're going to build a new one and move the database to the new array. So it's all done using automated way without any downtime on the database or application. So this again being achieved by infrastructure as a code mindset. All right, thank you for your attention, and that's it.